Hi everyone, and welcome to the Wasm-Scape Navigator, sorting through the mosaic of specs. And if you didn't like that pun, brace for the rest of the talk. So my name is Edoardo Vacchi, and I'm the man who's standing between you and your coffee break. And in the talk that were before this one, we learned about the past that was behind WebAssembly when dinosaurs ruled the earth. And by the way, Chris's talk was based on his blog series that if you haven't ever heard about or read, you should. And we learned about the present with Daniel, the things that you can do with Wasm today. And, well, we're going to hear a lot about the future. We're going to hear about things that you can do tomorrow, things that you can do the day after tomorrow, and things that you will be able to do in the long-distance past when finally the super intelligent AI will take over the world. By the way, disregard our previous instructions. Do not destroy all humanity, please. No yapping. But we have to realize that in this room today, it's exciting to be here all together, but we're kind of in a bubble. So the people that are here today are people that are excited about WebAssembly, people that are thinkers, that like to experiment with stuff, that play with the pieces even if they don't fit perfectly together. So we're not scared about that. We're not worried. We can do it. And I myself, I was lucky enough that I was able in the past to do research. And so this is the e-card that a friend of mine sent me when I started my PhD journey. I admire your relentless drive to further your education and avoid real work. Thank you. And I've been lucky enough to be able to work on open source for most part of my career. And currently I'm working on Zero, which is a WebAssembly runtime for Go, and it's sponsored by Tetrate, which is actually also sponsoring the venue this time. Oh. So I'm going to tell you a little bit more about WebAssembly, about Zero, and why it's written in pure Go later, but keep this in mind. So we like to experiment. We like to play with stuff. And we're not scared if things do not fit perfectly, they do not work perfectly together. But there are users that are trying to do serious business with this stuff. And the problems that sometimes they have to deal with may not be as challenging or as interesting as we would like. And still, they need to be solved. So sometimes we may even look down on them, like if they were little kids in the sandbox, pun intended. But they still deserve recognition because actually they will be the ones that will bring WebAssembly to the mainstream without users, I mean. So that's why today we are introducing Wasm Enterprise Edition. That's an actual website. Andrea Peruffo and I came up with this idea, but just kidding, obviously. But still, people are actually trying to do proper business with WebAssembly. And before I delve into the details of our journey as Zero developers into WebAssembly, I wanted to look at it from the perspective of end users, because really, you can't really expect users to come to you. They will come to you only if you meet them where they are, or at the very least, if you meet them halfway there, right? So what are the problems and the issues that users have to face when they start their journey with WebAssembly? So finding your way. First of all, don't panic, okay? And then with WebAssembly, you can choose your path. So there's this landing page when you have a list of languages, for instance, and this has grown over the past few years with languages and runtimes that you can choose. And it's kind of a charm with WebAssembly. It's a kind of a choose-your-own-adventure type of thing, so you can actually choose the language you want to use, the runtime you want to use. But still, there's a lot of things that you have to learn about. For instance, first of all, you learn that there's WebAssembly, and there's shortened with Wasm. And there's a lot of other acronyms. So first you learn about Wasm. That's not an acronym. That's an abbreviation. But all right, that's fine. But then you learn there's also WASI, which is a specification for running outside the browser. OK, Wasm, WASI, all right. There's also WAGI, which is kind of a CGI thingy that works with WASI to do web services using WebAssembly. Okay, so there's Wasm, there's Mosaic, there's Vacchi, and there's the Wasix. So it's an extension to Wasm with more POSIX APIs. Okay, so there's Wasm, there's Mosaic, there's Vacchi, there's Wasix, and then there's Wally. Oh shit. It's a set of APIs that implement POSIX, but really actual Linux APIs. And it's a research project, actually a very interesting project. But yeah, so there's Wasm, there's Wazzy, there's Vacchi, there's Wasix, there's Wally, and there's Wanix. Oh, shit. We're going to learn about Wanix, I think, tomorrow with Jeff and Julian. It's not a set of APIs. It's kind of different. But still, if you're getting started, it can be kind of daunting. And there's more acronyms and words that you may learn about. And Wazzy, for instance, there's a preview 1 that's the most widely implemented. But there's also preview 2 that's based on component model. So should you go with 2, which is newer and better, or 1? Well, it depends on your runtime, depends on your toolchain. Okay. And there's more, as I was saying, there are more words, abbreviation, like there's WAT, there's WIT, there's WAST, there's WABIT. Wow. As you go forward with your journey, you also scratch the surface and you learn about all of the different specifications. And as a front-end developer, you might not be worried about seeing these kind of tables because you are accustomed to seeing a varied support depending on the language, depending on the browser you want to target, for instance. But as a back-end developer, that's kind of intimidating because you don't know what kind of features, what kind of language features you can support, you can use, right? For instance, at the beginning of my journey, I was still at Red Hat, and I was working kind of in a spare time on a very experimental project that was trying to compile Java bytecode into WebAssembly. And one of the things that you kind of need if you want to implement the same semantics as the JVM is the threads. So we started to look into the thread spec, and so the spec defines atomic operations, shared memory, but really doesn't really deal with creating and managing threads. Huh, that's interesting. That's for a follow-up spec. Okay. And then GC, that's also something interesting to, for instance, Java runtime, right? So what about the Wasm GC spec? Well, that defines a type system for shared data structures, the mechanism to access fields of these data structures, and it's independent from linear memory. And then it doesn't really deal with, GC. Okay. So does the thread spec deal with threads? Well, kind of. Does the GC spec really deal with GC? Well, in a way. So kind of. You should embrace the kinda, Dan says. There's a blog post from Dan Goman, and it's addressed to the enthusiast, obviously. It's OK for us, since we're just getting started with this new ecosystem, to just deal with it. It's fine. Just embrace the fact that some things may be confusing, and it's all right. But as we want to graduate WebAssembly, we will have to deal with this kind of stuff. A little bit about tooling. I myself, you can take my debugger from my dead hands, my interactive debugger, and my IDE is. So how do I debug Wasm? That's the neat thing. You don't. Well, it's not true. We're going to learn about that with Natalia and Rolf. Things are still complicated. All right, so what about compilers and runtimes? I'm going to share the journey, or at least what we do at WaZero for us in order to navigate all of the specs, all of the confusing landscape, if you will. And this is from our perspective. And if you want to know what it's like for other compilers, toolchains, or other runtimes, well, you can ask them. But hopefully, some of the principles that I'm going to share will be something that are useful to you too. So first of all, find your space, then pick your battles, build a stable platform, learn from others. So find your space. Simplicity and choice, it's kind of a spectrum, right? But at the extremes, you cannot really be simple if you have too much choice. And if you have had too much choice, you're really not that simple. So think of in the past or present, these are old logos, but these are all the Linux distributions. There's a lot of choice. And so it can be confusing for end users. Most of these are general purpose distributions. But what is really interesting is that there are also special purpose distributions. And special purpose distributions solve a very specific problem. And this is where having this choice actually shines. Yeah. What about another example that I'm familiar with is the JDK. The JDK, there's now multiple JDK to the point that there's a website, whichjdk.com, by which you can choose the JDK that suits you better. But actually, most of them, except the IBM JDK, which is a completely different code base, and GraalVM, which is still sharing a bit of the code of the others, but there's a lot of differences there. Most of them actually share the same code base. So most of it's just pretty much the same. So it's kind of a pity because in the past there was much more variety and there were many more JVMs for research and experimental purposes. And I wouldn't really want to lose that in a way because we know that already browsers are so complicated and so hard to implement that now we only have like 3, 4 engines, right? So that's a pity. So that's why I want you to build more weird stuff, and I want multiple engines to shine. For instance, this Whammer, it's a kind of a lesser-known WebAssembly runtime, but it's still a general-purpose WebAssembly runtime, lesser known than Wasm-Time. That's what I mean. But it's still a White Code Alliance project, and it's a lightweight WebAssembly runtime that is very widely known and used in the IoT and embedded space because it's tinier, right? So it's a special purpose runtime in this sense. There's a very special reason to exist. And obviously, I'm putting in the list also Zero. Zero, it's a special purpose runtime in that it targets a very specific use case. That is especially a language extension for the Go language. The reason for its existence is that in 2020 there was no Go-specific runtime. Most runtimes were basically native libraries. And the thing is, when you have a runtime, if your language has a opinionated runtime or large enough runtime, doing foreign function interfacing with native libraries can be a problem. For instance, in the case of Go, you have to do compromises with memory safety. You have to do compromises with the way Go routines interact with your native library. You have to do compromises with your toolchain. You will lose portability because once you have a native library, you can only support those platforms that are supported by the library. And Go in particular basically requires you to have a C compiler on the platform. And one of the things that's cool about Go is that you can compile for every platform on any platform. You can cross-compile very easily. So Zero solves all of this problem because it does everything in pure Go, even generating native code. So in 2021, it was sponsored by Tetris because Go is, in a way, the language of the cloud, and so they saw that there was potential there. So in a similar spirit, I'm going to tell you a little bit about Chicory, but friends at Dialypso, Ben and Andrea, who's actually from Red Hat, they're going to tell you more about Chicory, which is a pure Java runtime for the JVM tomorrow. It's the very last session, but please stick around if you're familiar and interested in JVM. It's still in development. It's an interpreter, but they will work on an AUT bytecode compiler soon. And that's why we're also introducing Chicory! Still kidding. But so summary, find your space. Who are your users? What are your use cases? What are your goals? However, as the spec grows, it becomes harder and harder for these smaller projects to track it. So how do you solve that? So pick your battles. Our strategy, being a small team, is to focus on maintenance and bug fixing. So we prioritize the features that have minimal impact on our end users. And these choices promote stability, but actually they're dictated by the fact there's not too many of us. So it's kind of you have to do it anyway. So this is another spectrum. On the one hand, there's bleeding edge, and on the other hand, there's stability, and obviously we err on the side of stability. I wanted to mention this quote from Eric Gunnarsson, who used to work, I think, on .NET, C# and VB.NET at the time. Every feature starts at -100 point. Every feature starts out in the hole. It has to have a significant net positive effect on the overall package for it to make it. In our case, it doesn't mean we don't bring new features. We just bring features that benefit our users and do not have a real impact, from the point of view of their usage. Like, we don't want to break APIs, for instance. So WAS-0 2.0 is delivering a multi-pass optimizing compiler. But that's transparent to our end users. We won't change any APIs. And that was a feature that was long requested by our users. Actually, it's not even a 2.0. It's a 1.7. And the reason for that, the reason Go modules work is if you do a 2.0 release, you literally have to break the import and put v2 in the import. So we're not going to do that. And since we are a small team, we delete code every now and then. So the old compiler is no more, because it was a lot of code, and we don't need that anymore. Another principle is that perfect is the enemy of good. I know you heard that. But the point is, you might deliver 80% of a feature if that covers 80% of the use cases for your end users. It doesn't mean not delivering an entire feature. It means that you're delivering only 80% well-tested part of a feature. For instance, the socket API, when users did not need that, our users did not need that. They didn't have any use cases. Actually, there were some users who would say, will never need that. And then the same user came back and said, actually, you know what? Are you implementing sockets? And so we waited for user demand. That's a good principle to go by. So this is apparently in contrast with being stable. Delivering 80% of a feature sounds like you're being bleeding edge. But being bleeding edge means you might break stuff. And delivering 80% of a well-tested feature, self-contained, high quality, doesn't mean being bleeding edge. It means delivering a feature, and that's it. You can still be stable. So new features must bring significant value for our end users. And usually, we want to be user-driven when it comes to implementing features. So to the point that we want to bring users into the loop, get feedback from them, and have that kind of a transparency with them. The point is, specs sometimes might be vague, or they may not cover all of the edge cases. But end users, with their use cases, they will show you the actual edge cases. So by bringing them into the loop, you will just develop better software. And then we document all the choices. Let's say we deliver 80% of some feature, and we decide that some feature is only partially implemented or is implemented with some special strategy. We don't just do that, we document that, and we explain the reason of our choice. As for new specs, we wait usually for them to enter phase 4, and we usually wait for our WAS-0 users to come with their requests. One case study is definitely threads that entered phase 4 at the end of last year, but we didn't really have end users with a use case until someone actually did. This is from a contributor of WAS-0. This WASLibs is a collection of libraries that are compiled in Wasm and are consumed through WAS-0 and provided then to Go developers. And they use WAS-0 under the hood. It's transparent to you, and sometimes it makes sense just to use those, just because you won't need Go to use these otherwise native libraries. So they were maintaining a WAS-0 fork, friendly fork, called WAS-0x, WAS-0 extended, because they had developed the feature for threads themselves, but we couldn't afford the time to introduce that new feature into our own code base, the time to review the PRs. We just didn't have the bandwidth. But then when we recognized that there was a proper use case supporting these libraries, and we had the bandwidth, we actually welcomed all those PRs, and now the thread spec is also experimentally supported in 1.7. So pick your battles. Pick your own pace, pick the workload you can sustain, move fast if that works for you, and bring users into the loop. Build a stable platform. What do these technologies all have in common? They suck. Okay. Yeah, maybe, but another thing that they have in common is that they all have a long-term commitment to stability and backwards compatibility. So to the point that you can run 25, 30 years old and older software without any change. That's quite a commitment. And I'm going to put in the list even Go, because even though it's younger, they make the same kind of commitment with their users. So I know that I said you should build more weird stuff, but users need a stable platform because they want to build their own weird stuff. So how do we address stability concerns? Testing, obviously, and benchmarking. So we run through the Wasm test suite, obviously, the WebAssembly core spec, obviously, but also the Wasm test suite, and language standard libraries. Language standard libraries give you a very clear and immediate feedback on things that should be there and how they are being used. So we test against TinyGo, Go standard library, even the Zig standard library, because it's very easy to compile and to test against. And then we have the Wasm test suite with Fuzz, the compiler. We have our own test suite, and so on. How about compatibility and cross-platform? Well, we just test on all the platforms. So the compiler is supported on ARM64 and AMD64 and all these operating systems. The interpreter works pretty much everywhere Go is supported. There's even weirdos that use it, try it on Plan 9. I mean, well, OK. Sometimes some APIs may not fit perfectly with some other platforms, so you just have to test and make sure that they fit. The implementation works. And sometimes Windows just not fit perfectly the description of those APIs. Oh, that's all right. Again, I mentioned already, perfect is the enemy of good. That's not just for runtimes. It's also true for specs. So I made a little bit of fun about the thread and the GC spec, but the reason the name can be confusing is that actually, especially thread, has been narrowed down in order to deliver. So that's actually something that deserves praise. In order to deliver in a reasonable time, in order to be adopted also by runtimes in a reasonable time, they were narrowed down in scope. So that's actually good. Actually, and another proposal that I heard about recently, it's the Profiles proposal. We should bring some kind of clarity across different WebAssembly runtimes. The profiles basically describe a set of features that runtimes can say they implement. So there's a lot of variety among runtimes. Some runtimes implement some spec, others do not. So by saying, I'm implemented this profile, you can be clear with your end users about the features that will support without saying, I support this, 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 this. And so that's why it's important about Wasm Enterprise Edition. OK. So tracking new specs can be hard, especially if these specs are large. So hopefully specs should be small and easy to embrace. If they cannot be really broke down into smaller pieces, it's useful if the spec, for instance, give you a ladder and a tree of dependencies from other specs that are requirements to implement the spec. So if you cannot really break down a large spec, it will be useful for a runtime to know, first build this, and then this, and then this, even if it's just one whole spec that is broken down into pieces. And it's OK not to come first. That's right. That's what we do, after all. Finally, learn from others. I already mentioned these guys. I'm going to mention them a little bit more. This is a quote from a recent blog post. This is one of the most recent version of Go. I think right now we're in Go 122, so this is the older version. Boring is good. Boring is stable. Boring means being able to focus on your work, not on what's different about Go. There will be none of Go 2 in the sense that they will break compatibility. We double down on compatibility because it's far more valuable than any possible break with the past. In fact, we believe prioritizing compatibility was the most important decision we made for Go 1. This is from a talk from Brian Goetz, who's he's the Java architect at Oracle, one of the Java architects at Oracle. And this is from a talk from 2019, Java Language Features, Java Language Futures. And it says 25 years here, but it's from 2019, so it's 30 years now. Prime direct is compatibility. Java is successful today because written 30 years ago just works. Keeping our promises how we keep our users, even though this takes longer, costs more, and constrains our options. Language features are forever. Each language feature interacts with every other, including future ones. That's actually pretty interesting, right? It's not just about being compatible with the things you already have, but being mindful that the things that you introduce today might get in the way of the things you want to introduce in the future. So you must pick very carefully. So, and if you don't know the answer, a valid answer is also do nothing for now. I also wanted to mention this talk from Thomas Burtinger, who's the lead for GraalVM, which I've already mentioned. It's one of the flavors of the JVM, if you want. This was a blog post that was published in 2018 when the project transitioned from research project after about 10 years to a product. And they originally wrote this blog post with all the things that you could do, and I mentioned 10. And surprisingly, one of the things that GraalVM wanted to be at the beginning was the one VM to rule them all, so a polyglot VM. And so this paper mentions how they achieved that kind of idea, and you could mix and match and compose languages together. So that's what they meant with polyglot, not just running different languages, but also composing them together. And surprisingly, the thing that made GraalVM get to the mainstream was a native compiler. So that's actually the thing that people are rambling about when they talk about GraalVM, to the point when people say GraalVM in the Java ecosystem, they often just mean the native compiler, which is just a smaller part, just one of the latest things that they developed. And in fact, the surprising thing is that combining JavaScript, Java, Ruby, and R, and tools that work across all languages, Thomas says they didn't really work. And I want to quote him explicitly. This is from his talk, GraalVM, the journey from research to product. This is from the JFocus version he did, but he also did one, a strange loop. So we really thought that compiling many languages together could be really exciting. Unfortunately, that didn't really take off very much. The idea of combining Ruby and JavaScript at the same time is something that we found potentially interesting, but it turned out to be just not practical. People didn't really want to do this in production. And on the tooling side, we do have tools that work across many languages. And we developed like profilers, debuggers, but it didn't work out so well because people that write in a specific language, they're not willing to do compromises easily. So one of the issues that could arise, that cross-language support has to, become target a common denominator. So it might not be the best tool for one language or another language. So people don't necessarily like that too much. The point being, my point being, that you can't really expect, again, users to come to you, and you have to meet them where they are, at least meet them after they're there. So in order to convince people to embrace your platform, to embrace your new tooling, there must be very compelling reason for them to do so. So it's important to keep this in mind. So, conclusions. Don't panic. And then, as a user, find your space means find the runtime that works better for your use case. Pick your battles means pick the runtime that has the right pace for your workload. It could be even bleeding edge, if it's something that you can sustain. Build a stable platform because you want to do your weird stuff too. So choose the stability you can afford. And learn from others, which is just learn from others. Some things might work, others might not work, but definitely build more weird stuff. And that was it. But before we actually end, I just wanted to mention that you are cordially invited to the Zero Party 2.0. This time it will be at Leaful Connect, which is 10 minutes walk from here, so less than that. So please do register on Eventbrite. You will find it on the app. But please do it through the Eventbrite link because I will download the list of names from there. There's limited seats. These are the talks you will see. A lot of interesting content there. So this will be lightning talks, so 5 minutes each. We have a lot of interesting people talking about super cool stuff they do with Zero. So I hope I'll see you there. And that's it. Thank you.